So, this is week 7. We talk about entity relationship model. Okay, so there are several important keywords you need to know. First is entity. So, entity is object of the interest to the end of the user. So, in the entity relationship model, is the entity refers to the entity set. So, which means is a table. So each of the table we consider is entity. Um, if you want to make instance of the entity, that is the row. Okay, so each row of the table we consider is instance. Each of the table we consider is entity. Okay, so what is the attribute? We have a lot of attributes for each of the um, entity. So in the table, we consider the attributes is a column. So each column they have a unique. Each table they have a unique attribute. So in the ER diagram, the ER model, the attributes is characteristics that can describe the entity. Okay, so that means these attributes can help you to describe this entity. Okay, for example, student table. Okay, for example, we have students table. This table could have attributes like student's last name, student's first name, student initials. So those the attributes which can describe the student. So in the diagrams, we're using the chain notation and the Crowfoot notation to demonstrate the ER diagrams. So this is a Crowfoot diagrams. So you can see this is the entity's name. Those here are the entities, the entity attributes. Okay, for the chain model, so rectangle we consider this is entity. Okay, oval we consider they are attributes. Okay, so different diagram they're using a different way to draw the diagrams. So we do have some attributes is required, some attributes is optional. Okay, required attributes, that means this attributes have to has a value. For example, in here the Crowfoot model, you can see this is board. So once you see the board, the font, that means they are required. That means the students is required to fill their last name and the first name. For the optional, that means you can leave as a blank. Okay, for example, in the initial, email, phone, they're not bold. That means they are optional. So students don't have to has value for initial and email and phone. Domain, this is very essential the concepts for the ER model. So domain, that means this is a set of the permissible value for attributes, because each of the attributes you need to fill in the value, but we need to make sure the user can fill the right value into there. So for example, you ask people to fill the social security number. Okay, that means you cannot fill with any other letters. You have to be number. Okay, and you need to set what's the range of the number. Okay, so the number have to how many digits, right? So this is a domain. So based on the type of the attributes, how you define the attribute, you define your domain. So in here, for example, if you have an attribute called a GPA, so the domain should be a range from 0 to 4, right? So the date of the hire the domain should be a valid date range. Okay, so the key point is domain ensure the data consistency across the attributes. Okay, consistency of the um, cross the attribute. So in the model, there is something we call the identifier. So identifier, basically there are the keys. Okay, so there are the key that can uniquely identify this and this. Okay, this entity. So for example, one of the table for students, we probably has attributes for like a social security number, student's ID. So either one of the attributes can be the identifier because they can uniquely to identify these entities. Okay, so identifiers are underlined in both chain and Crawford's notation. Okay, this is one of the example we can write down using a relational schema. Okay, if a student, we have student ID, this is underscore, that means this is our identifier. Okay, it's the primary key. Okay, so primary key can be one or multiple. So multiple, we consider they are composite identifier. Okay, so that means this primary key composes more than one attribute. So for example, we have a class. In a class, right here, class, we have course code and class section. Okay, so how you can identify this class? Okay, we need to make sure we include their code and the section. Then you can refer the right class. Okay, because different section, they probably will give you a different time. So you can see there, this is course code, this is a class code. So you can see this is different. Okay, so this one is unique. Okay, but course code, they are not unique. So you can see there, those, some of them are duplicate. This is duplicate, duplicate, duplicate. Okay, so 3 of them duplicates. How you differentiate? You can using 1, 2, 3 the sections to differentiate. Okay, so you can see we can combine the course code and the class section together as one primary key, or we're using one of them as a primary key. So it depends how you can, you choose the, relationships. Later we will talk about it. Okay, so multiple attributes can uniquely, okay, also can help you to uniquely to identify entity instance. This is one example. So you can see the class. In this class, as we said, the class code, which is underscore, that means this is something we can consider like unique, the single primary key. Okay, because none of them are duplicate. At the same time, they can help you to identify each of the courses. Okay, it's unique. Okay, or we can choose the different way. We can use in the CRS code, course code, and class section. Combine them together is also the way we can identify each different class. Now, we talk about entity relationship. So what is relationships? So relationships is association between entities in a database. So we have so many different entities in the database, but how we can associate them, how we can link them. Okay, so this is something we need to make sure you can understand. Okay, so entities involved in a relationships, we consider this entity is participant. Okay, so relationships usually are described using a verb. For example, student takes class. So student is a participant. Okay, class is a participant. Relation between the student and the class is takes. Okay, takes. So professor teaches classes. Professor's identity, class is identity, teach is relationships. Right? So another example could be a customer generates invoice. Okay, a customer generates invoice. So customer is identity. Invoice is also identity. The generation, generate is something link them together. So by nature, okay, so all the relationships are bi-directional. For example, we say customer generates the invoice. Okay, so invoice can be generated by customer. So this is always by direction. So now we try to give you guys some of the key terms which is used widely in the database. One of them is connectivity. So this describes the relationship, classification, one to one, one to many, okay, one to many or many to many. So the many to many we write down as m n. Okay, one to one, just one to one, just one to one. Cardinality, let's specify the minimal and the maximum number of the occurrences of the related entity. Participation, specify whether or only some of the instance of the entity participate in the relationships. We'll talk about in an example. So this example, we're trying to describe professor teaches class. So in this one, once you see here one vertical line, this is one. This means one. If one plus this arrow means many. Okay, so now you can see here one, many. So when we see here is one and many, so connectivity is one to many. Okay, that means one professor teaches many classes. Okay, many classes. So this is one to many relationships. So cardinality, it means minimum and maximum. So when you see here, the first number is about minimum, and the first number is the minimum of the class. Okay, the maximum of the class is right here. If we go this direction, and that means one professor teaches 1 to 4 classes. Okay, so you can see here 1 to 4 classes. Because we know all relationship is bi-directional. So class, so when we see this, we need to say each of the class is taught by how many? One professor, maximum, and one professor. That means only each class is taught by one professor only. So what's the participation? Participation, that means from this end, you can see it's one to many. In this end, it's 1, 1. That means both of entity have to involve in this relationship. Okay, if it's have to, that means it's mandatory. Every class must have a professor. All right. every professor have to teach a class, right? So this is basically the key terms, how we describe the connectivity and the cardinality and the participations. Okay, so there are many different examples. This is another example. It's youth basketball league. So when you see this one, this circle, that means it's 0. Okay, it's 0. So one team. So when you see here, it's 1 or 0. This one too many, right? So connectivity between this team to the player is one too many. Okay, so that means one team can have many players. Okay, however, if we include with this cardinality, okay, so it means minimal and the maximum, minimal and the maximum. So how we describe this? So one team can have 5 to 8 players, right? However, if we describe from player to the team's direction, is each players belong to one team or no team. Okay, so this description tell you, okay, the cardinality. What's participation? Participation, that means right here is optional or it's mandatory. So from player is optional to a team, but team have to has a player, right? So now this is an example. So every team must have at least 5 players. So for team is must, for the player is optional. Okay, this is participation. Now we talk about weak relationships. A weak relationships occur when two entities are connected, but the child entity does not rely on the parent's primary key as a part of its own. This gives each entity more independence. Okay, so what do I mean? This is one example. In this example, the course, you underline this course code right here. Course code is primary key for the course table. Okay, because the PK right here, that means it's primary key. However, right here for the class, we didn't use or we didn't include the course code in the part of as a part of the primary key for the class. Okay, even they do have, but they are not part of the primary key of the class. That means it's weak relationships. Okay. However, we talk about weak relationships, we always have stronger relationships. Stronger relationships ensure the child entity is closed, tied to parent entities through the shared key component. So in this case, we move up. We're using the class section and course code as a primary key. Now we make this class, and the course highly relate and rely on each other. Okay, so we also have a different type of the relationships. One is unary. Unary is also called the recursive relationships. That means the one entities, they can call each other. They can relate to each other. For example, employee is married to employee. Okay, so one of the employee can be married to another one of the employee. Employee can manage employee, right? So instance of the employee can manage another instance for the employee. So this is one example. You can see we have primary key is employee number. Employee number is right here. So employee is married to another employee. So you can see this is an employee number. This is an employee number. So these two married will happen in the same table. Okay, so next one is one too many. Okay, one too many. So ordinary also you can take like one instance can manages many employees. So for example, in right here, so we have employee code right here. So one employee, they have the many managers. So you can see the manager is this guy, and he or she can manage all of them. Okay. At the same time, we can do the many to many. Okay, many to many. Then it's binary. So binary relationships exist when two entities are associated with one another. This is the most common type of the relationships in database design. So such as the example we already have, for a professor teach one or more classes. So this is one example, professor teach, zero, this is right, zero too many, okay? Zero too many. That means they don't have to teach. It's optional to teach the class, but they can teach many if there's no cardinality. Okay, so we have multiple entities. It's more like conceptual. Okay, doctor can prescribe the patient and the drugs. So those mostly we don't have this one, but when we discuss, we probably have this conceptual, relationships. It's more, complex one, because sometimes because when we talk about this, we probably need to add another entities to in case, they probably can interact with one use case, the entities in one diagrams. Okay, so this for this week.